Number 12 from the test. F of x equals x to the fourth minus 3x cubed plus x squared minus 3x. And we are expected to find all the zeros of this function.
Take away an x.
Sounds good. You don't really mean take away, but we'll do what you mean.
Yeah.
Right? Factor out an x. I love that idea. Let's do it.
Take an x out.
I can't believe you counted all my points wrong in this problem just because I copied something wrong.
What are you talking about?
I was rewriting the problem and copied one of the numbers wrong and got the entire question completely wrong.
How do you know it's completely wrong?
Because it's minus 18 points.
How many points is the problem worth?
I don't know.
What number?
You crossed out everything.
What number is it? 10 is worth 28 points. So you got some of them.
You have one number that's actually
Anyway, what now?
You gotta figure out the factors of 3 and 1.
Okay. Factors of 3 are 3 and 1.
3 works.
And 1 and 1. So, what are the possible rational zeros? Plus or minus 1 and plus or minus 3. Great. What other tool do we have in our tool belt that could help narrow it down and guide us for our future?
So real.
Yeah, the positive, negative, real ones, right? So how do we figure that out?
The changes.
Swap the odd powers.
Okay, so the changes for the positive real numbers, yeah, we're going to get to that in a second, right? The positive real ones, how many changes are there? 1, 2, 3. Okay, so f of negative x is negative x times, we don't really care about that one. That one's irrelevant. Negative x cubed minus 3x squared minus x minus 3. Oh, that's nice, isn't it?
There's 0.
There's no changes, not a single one. There's not a single change. How many are we looking for total?
3.
We're looking for 3. We have one of them is 4. We're looking for 3 and 3 only. And there can either be 3 positive ones or 1 positive one, right? Because minus 2. There aren't any negative ones, which is really great because we can cross out those possibilities. Narrow it down to 2 possibilities if it's a rational zero. Right? If there are 3 positive ones, how many imaginary are there?
0 over 2.
0.
If there are 3, there are 0. If there's 1, then there's 2. Great. So now what could we do?
Change the cardboard box.
Yeah, we're going to start dividing stuff. What are we going to divide?
3.
Sounds great. Let's pretend like we picked different and picked 1 for further learning, right? What numbers am I going to put over here?
Negative 1, negative.
No.
Wait.
1,
Negative 3.
negative 3,
1.
1, negative 3.
I see. No, that's not properly.
1 times 1 is 1. Negative 3 plus 1 is negative 2. Times 1 is negative 2. And negative 1, and, oh, that doesn't work.
Oh no.
Oh no.
Oh no, let's try 3.
Try 3.
1, 3, 1, 0.
Bring down the 1. It's definitely not Morse code. Morse code doesn't have any 3s in it.
No, the bottom, the answer.
Oh, it's probably binary. Is that what you mean? Yeah. Okay. 3 times 1 is 3. Negative 3 is 0. 0. 1. 3. 0. It works. Now what?
It's binary.
Yeah, that's what we...
Now
You do x minus 3
you make a
times.
equation.
times,
We don't even really need to worry about that one anymore. 3 is part of the answer.
Yeah. Now you make the not the quadratic thing, but you add it.
It is going to actually be a quadratic in this one, so you were accidentally right. Right? You make the depreciated equation. What is that going to mean?
it's gonna
I know.
be
I know. That's why I said you were accidentally right and wrong all at the same time. It's great. So what is the depreciated equation going to be?
x squared minus
Plus 1.
plus 1.
There's no x term, right? 0x, yeah? Equals 0. Now what?
Now you put it equal. Wait, where did we get that x squared?
So the first one is always 1 less degree than where we started. So that's why it's x squared. And it's 1x squared. And then the next, so it would be x squared and then x and then no x, right? But there's not an x one. So there's not, so it's like 0x is right here, right? And then plus this one. And equals 0. Okay. Now what?
Subtract 1.
How about subtract 1?
Why can't you put it?
You could, but this is so much easier. Because that you're going to be wasting a lot of time because there aren't any more real zeros. Which we're about to prove by doing this math.
Do the same answer.
Well, you can't get the answer a different way. Actually, you could. No, you couldn't.
Put it into this formula, you get the same answer.
Oh, in the quadratic formula? Yeah, I mean, that's kind of a pain in the butt. But yes, you could use the quadratic formula at this point. That would be possible. What should I do now?
The square root of negative 1. Oh no, it's I.
Nope, it's plus or minus I. So the answers for the zeros are 3 and plus or minus I.
Okay, so why'd you count off and tell me to put a 0 right there?
Oh, thank you. Great question. I forgot like you did. How many zeros does this actually have? Not 3, it has 4. One of them is 0. Because of this one that we factored out. That makes sense?
Yes.
Okay. What questions
11.
do you have? Does somebody else have a question first? 13.
I just think I'm going to do the last step.
The remainder is the answer.
Yeah.
So-
Yeah.
Okay. 13. Oh yeah, 13 is the fun one. I like 13. It's a great problem.
Yeah, I think I just reduced.
What?
That's annoying.
It's spooky.
Grab your flashlights, guys, and stick them on the table.
Especially annoying because I don't think I have any Sony batteries with me. Let me see if I do.
So much.
Oh, is it just our room?
Nope, that room.
Oh, well, give me a second then. Weird. Wonder what tripped the breaker.
Get back on now.
Yeah. It's weird. I don't know what would have tripped the breaker.
I've heard one of these on, but without a
I don't know whether it's on the same circuit or not. We would have had to have checked it.
went off, or it went off, so,
Oh, it did turn off?
yeah, so maybe.
So maybe something with that.
That plug, yeah, maybe then,
Weird.
yeah.
There may be some that could indicate that there's some sort of short or something in one of those or something.
Yeah.
We'll see. If they start smoking, unplug it. Okay. Oh, that's good. That's easier. Okay. What are we doing? 13. Great. I like 13. It's a great little problem.
I tried way too many numbers.
Yeah, you did.
So did
But I didn't get it wrong.
You're the one that saved us, remember?
Yeah, I am. But
2/3.
I didn't get it wrong. So.
I didn't reduce all the way.
Yeah.
I just heard Malcolm say 2/3 and shoved it in there.
So I mean.
I was doing negative 2/3 when you said that, and I was like, I guess I'm just gonna take away the negative.
Okay. What should we do?
We
Should
should
find all of the.
What? Let's do the changes. Great. We'll also do your suggestion. How many changes are there? Two. Positive real numbers. There are either 2 or 0, right?
Yes.
F of negative x equals negative 6x cubed plus 5x squared plus 9x plus 2. How many changes?
How do you know what ones to change?
It's always the odd exponents because if you put a negative in here, it's going to turn out positive. So it's always the ones with an odd exponent.
Oh, okay, gotcha.
Great. How many changes?
One.
Handy.
One.
Handy. We like ones. Ones are great. Even threes are okay. Hey, because great. How many are there total?
There's 0 and then.
There are
Three.
3. So if there's 2 positive, 1 negative, how many imaginary? 0. If there's 0 positive, 1 negative, how many imaginary? 2. Great.
2.
Now what?
You make the cardboard shack.
I would give us some options first if it were me.
Well, it's,
Yeah,
We
well,
would
you
get
know.
all the possible.
Possible factors of 2 are 2 and 1. And possible factors of 6 are 6, 3, 2, and 1.
Or plus and minus all.
Well, I haven't written it all out yet. So, right, 1 over 1, so plus or minus 1. 1 over 2, plus or minus a half. 1 over 3, plus or minus a third. Bless you, I think. 1 over 6, plus or minus a sixth. And then 2 over 1, plus or minus 2. 2 over 2 is plus or minus 1. 2 over 3 is plus or minus 2/3.
Circle that one.
2 over 6 is 1/3. We've already got that one. Those are our possibilities. So it's the factors of the constant over the factors of the leading coefficient, which is, I'm pointing the wrong one. It'd be these ones, but we actually don't care about the sign because it's always plus or minus. So whatever. Okay.
Try 1 and then try 2/3.
So I gave a hint, so we should try one of this one, this one, this one, or this one, right? You should just skip these because I put a hint that said has a non-integer zeros. That was flat. That was saying try the fractions first.
Then no one listened.
We all wanted that one to work.
We're like, no.
Okay.
I've won so many times.
So let's try 2/3.
Yeah.
Bring down the 6. What's 2/3 times 6?
4.
4. 5 plus 4 is 9. What's 2/3 times 9?
6.
6. -3. -3 times 2/3.
-2.
It works. Grand, glorious. So one of the zeros is 2/3.
And
Now a quadratic formula, right? Because the depreciated equation will be 6x squared plus 9x minus 3 equals 0. And I think y'all got it from there.
Do we?
Well,
Yeah, just reduce at the end.
It is a quadratic form.
okay, I have a question that's not necessarily to do with one of the problems, but I did get it wrong.
It's relevant.
Yeah, it's relevant. How do you write the remainder
So,
I know the fraction, but how do you calculate it?
like on number 3, the remainder would be plus 462 over x minus 3.
Okay, it would be plus.
Yeah, because it's positive.
Okay, I was just multiplying it.
Yeah.
Can we do?
How do we do 8?
How do we do 8?
Yes.
With math, probably.
8 and 7.
Oh yeah, 8 you just have to remember.
Yes, both of these sound like amazing.
7 you should have been able to do. Just say it. 7.
I was overthinking it.
Probably so.
I forgot how to do it.
8 you just had to remember the formula.
7 I messed up, but I'm not sure how I messed up.
Well, we'll do 7 real quick. Fine. I think I had one person get it completely right, if I'm not greatly mistaken. But it might be more than one. But I think there was only one that got it 100% correct. I think.
Izzy got it 7.
Yeah, it's the difference of 2 squares. So you do plus or minus, you factor it and do plus or minus.
It is the difference of 2 squares. So yeah, we do open, close, x squared. Square root of the second one is 4 and 4. Plus or minus. We're not finished
Yeah, because
yet.
minus 1 is still different.
We have another difference of 2 squares. So we have to factor that one as well.
Oh, that's right. You can't do it. Okay. That's okay.
And bring that one down, right? If you say so.
Well, because I've been messing up on these since Algebra 1.
So you finally got it. Good job. 64x cubed plus 125.
Actually, it's A.
Whatever, don't care.
Something is so easy.
What should I do?
It's
Figure out what the
What is the formula?
A. Find A and
What is the formula?
formula is A plus B times A squared minus AB plus B squared.
thought it was plus.
That,
No, signs are same different. So on the difference of 2 cubes, it's negative, and then these are all positive. Same different.
What is this formula called?
This is called the sum of cubes.
Okay, so I had it mostly right. I was just missing the sign.
So yeah, and then it is quite useful to write out what A is,
How do you find A?
the cube root of the first one.
Okay. So I got that one right.
So what is A?
4x. Or
4x. And what is B? Cube root of the second one.
It's 5.
5. So then this will factor into A plus B, so 4x plus 5. This problem, when I wrote it, and if I would have remembered this year, I would have gone back and changed it. This problem was supposed to have this part be factorable, but it is not. Shucks.
Oh, shucks.
And then A squared would be what?
16x squared.
16x squared.
I had the right.
And then A times B would be what?
Negative 28. Or, well, 28.
Yeah, that is what I meant. 20x on the version I wrote on the board.
I read mine.
And then B squared would be 25. And there we go, because you can't factor that.
I tried, and then
I intended to make one that was factorable, but I made a mistake something last year, and there it is.
It's all messed up. Okay. Can we do the homework?
What was the answer for 5?
5? Is that the one that's not a polynomial? Yeah, it's not a polynomial because of the negative exponent.
I said negative, whatever that's called.
Yeah, I don't think I even counted it off. I think I'd let you have it. Number 6 is totally a polynomial. There's nothing wrong with a fraction on the coefficient. So for the 2.5 of you that put that, I don't know. I don't remember how many people did it. Several people said 6 was, multiple people put 6 is not a polynomial. It is. It's totally fine. All right, homework time.
Oh no, my test.
Just take a breath and wait a half a second.
Okay, I thought you were sitting on there permanently or something.
It's okay. Pattern recognition is hard sometimes, along with impulse control. Operations on functions. What numbers did we do?
8 through 34. And I
8
actually-
through
And
34.
I accidentally did 36 and 38 too.
Good job. I'm trying to decide whether it would be easier to shove these up on the television. I think it would be because there's a lot to read. So I'm just going to shove it up on the television. Okay. You're not in kindergarten?
Sure about that? Her maturity level's got there.
I don't know if maturity level is the word choice I would use. There might be a word I would put there, but I don't think maturity is the one.
Personality traits are that.
Oh no, Landon, you're missing the challenge.
What? It's an ad. It's an ad. Great review.
It's so funny. People on the internet are missing it. Oh no.
They combine time and capital.
It's a sponsor.
I can't read that.
Yeah, either.
They
I
just
need
like,
my eyes checked.
I can see it says additional.
If y'all will wait a half a second, I bet somebody will zoom in. I bet.
I put them on one day and they gave me a colorblind test and I got 4 out of 20 correct.
Nice. There is 8, 10, and 12. Just my, yeah.
I labeled, but
Well, y'all look at those. I'm gonna make some coffee.
Oh, I see what I did there.
Good.
Oh wait, what? Shut up.
You didn't read 8?
I didn't read it.
I need
Oh my gosh, y'all are so slow.
We're going as fast as we can.
to find the answer.
Not that rude.
I want to hear what you're talking about so that Steven will get through it.
Use the key.
Pick me up again.
Oh, yeah? Olive? No.
Oh my god! No! Why are you like this? Turn it back! Jonathan.
Jonathan?
Jonathan. Oh, that's nice.
It's Shaquanda, get it right.
What did I do on number 4? Did I not do that?
Probably. We got more answers to go through, but
Where are we now? At the top.
I was just looking at what time it was because I didn't put my watch on. Okay, number 16a, f plus g of x equals 375x plus 10, and 16b, f minus g of x equals 25x plus 40.
Wait, what was A again? Sorry, I'm sorry.
375x plus 10 equals f plus g of x. 18 supposedly is in the margin on the next page. Okay, great. Here we go. Me up again. I wouldn't go that far, but
Did you not hit the second?
oh.
like 18 through
None of
20.
us did any of these.
None of us even knew how to.
Well, I
Wasn't it-
probably should have said omit, but you know, whatever. It's fine.
Our brains were
They're not actually that hard, but
Yes, they are.
Our brains were too good.
Yeah, see, you can try if your symbol work, but we can read.
I will throw out there, just like, I mean, you can cry if you want. If you prefer the crying method, you know, go for it. But, you know, you can look at, like, the book lesson part. Oh, okay, good. Okay. Okay, well, that's good. That's good. At least you attempted that. Good.
We attempted it and failed.
It made 0 sense.
The word,
There's some more problems.
that we don't know how to do.
Well, you do know how to do 28 through 34.
Yeah.
Hello, machine.
Hopefully I can. You know, if I try.
Well, there they are, so you can see whether you knew how to do them or not.
I got it right.
Fa la 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 la.
F was B.
Don we now are gay apparel.
Are you reading the right number?
I should totally like give you bonus points for that. That was epic. She doesn't even know I'm talking to her. You
Wait, we're doing what?
for joining in with the wild and crazy singing.
Why did I get that one wrong?
Probably because you did the math wrong.
I trust you.
Why do you have the less than equals 2 thing?
Why do I have? I think you're confused.
Why does the book have the less than or equal?
I think I meant to write 44, but I just put a 4.
We made the same exact mistake.
What am I doing?
Trust me, 'cause I make the same mistakes as you.
And there's 34.
54.
And now I have to say, what questions do you have?
A lot.
14. A lot. Oh my gosh. You people. All of them. Shut up. You know what's really annoying is half the time when somebody's like, all of them, they aren't actually that confused. They're just being a big baby about it.
Oh, I
Most of them. How's that?
Which one?
keep doing the second one.
Okie smoky dokey.
We're doing 8.
We're doing 14. Where's the button? There's the button. Okay. Number 14.
Oh, it's because you're supposed to. Oh, no, it's not. What am I doing? We're smart. We just didn't have a note page.
Do we need all of 14 or just like one or two of them? Division one? Yeah. Yeah. That sounds more accurate. I would be surprised if we had a ton of trouble on the other. We could. It's not impossible. Sometimes we don't know what we don't know, but.
I think I just distributed.
I'm gonna-
You distributed the dividing ones? No. How do you distribute the dividing? On the later
This particular unit, I will throw out there on this particular unit, if for some reason, I don't think this is true of anybody in here, but I could be lying. And if I am, I'm talking to you. If you are shaky on factoring, you should work on that because you will die in this unit if you're shaky in factoring. So make sure you can factor. It's okay. And I've said this before, like gaps are okay. Recognizing gaps is even better. Not filling gaps is foolish. So like go fill the gap. You can do it. I have faith in you. If you need my help, let me know and I can help you. But make sure you're not shaking on factoring. Okay, so let's do f times g of x. All right, let's start with that. What do we do with that?
A lot of distributed.
A lot of distributing. That's absolutely accurate. Right? Distribute this one. Negative x squared times 2x squared is negative 2x to the fourth. And negative x squared times 3x is negative 3x cubed. And negative x squared times negative 5 is positive 5x squared. And then distribute these, right? 6 times 2x squared is 12x squared. Plus 6 times 3x is 18x. 6 times negative 5 is negative 30. Then what do we do? Yeah, we find the like terms and then combine them. So these ones, and that's it.
Nice.
So then the answer is all of that except these smoosh to be 17x squared. Let's do the division one. F divided by g of x equals negative, oh, that's interesting, x squared. Sometimes in this class, my brain starts thinking in a pre-cal brain. No, because I don't usually like tell you the confusing bit, so it's okay. It's actually not that confusing. Sometimes, it is sometimes sad for you because sometimes I'm like, if you knew how to do this, we could do it this way, but that's not very often because pre-cal is basically this class with graphing calculators and trig. Ooh, the best. In public school, yeah. Yeah, I think that's stupid. I think that's a giant mistake. I think giving students calculators period too early is a giant mistake. A mistake that they keep making. Honestly, about 80% of the special ed kids that they give calculators to way too early, that is messing that kid up. Stop doing it. It's stupid.
They gave me a calculator in 5th grade.
Yeah, they do. And giving graphing calculators too early is a mistake because people don't actually learn how to graph and do other things, and then so they don't understand what they're doing. They're just shoving stuff in the calculator, and then when they get to higher math like this, they're like clueless because they don't know what they're doing. So yeah, no, it's definitely a mistake. You'll be happy if you take pre-cal next year and you come in and you're like, oh, I can just put that in calculator and it tells me where the stupid asymptotes are. Great. That's a foreshadowing for the rest of this lesson, by the way. Here we go. So what could we do to clean this up? Because this is the answer, right? But if we can simplify it, we need to simplify it. Yeah, we do.
Are you able to take a GCF out?
So you could look for GCF. There really isn't one. We could factor a negative out of the top if we wanted to, but there's not really a GCF.
But you are able to do that.
Yes.
Factor the bottom.
We could make a good effort at trying to factor the denominator. I like that plan.
Looks factorable.
So 2x and x, right? And then what?
5 and 1.
I'm glad you said that way.
No, dang it, I wrote one.
Can we add or subtract that to get 3? No. So what can we do now? 1 and 5.
I technically have my.
Did I not get my? Oh, I didn't.
Good job, Sean. You did.
One and 5. 2, 5. Can we add or subtract those to get 3?
Yes.
Put a 2. Put a plus. Follow our nose and our mouth. And sad day, nothing cancels, but you know. I would argue, now this is debatable on one piece of this, I would argue that this right here is the best choice for this, for the answer to this problem. Because it gets the negative off of that squared term. Although if you left that in and left the numerator just like this, that would also be fine. I wouldn't count off for that.
You need to add another parenthesis.
Thank you. I wouldn't count off for that either, actually.
No, but it looks
Yeah, it's definitely a better plan. For sure, I agree. Makes sense? Easy money?
How do we find the domain and range of these problems?
Of the
Because they
last
ask
four,
for the.
the last
just in general.
So domain in this as well as several units moving forward, it's easier to think about what X cannot be. It asks for the domain and the range. Are y'all sure about that? Or just the domain?
It does say domain.
Oh, okay. That's a little bit more annoying, but it's fine. Okay. Anyway, it's easiest to think about what X cannot be instead of thinking about what it can be. That's easier at this point. So, how do I figure out what X can't be? And yeah, good. Let me shut up because you were going to answer the question I was about to ask. What are you saying? Go ahead again. Or fine, I'll ask the question, and then everybody can hear me because I was talking to you. But that's fine. What number somewhere in this problem, whether it's X or whatever, would make this problematic?
The denominator.
What number in the denominator would make it a problem? 0. So if all of this was 0, that would be a problem. So we set it to 0. We've already got a factored one, right? So when we set this equal to 0, we end up with x equals 1 and negative 5 halves, which means the domain is that x cannot be these. We're in Algebra 2, so we write our domain and range in interval notation. So how do we write this in interval notation?
Okay.
X is that the greater than or less than? No, X is infinity. Oh, I remember sort of. It's one where it's like a parentheses and then bracket on the other side.
Yeah, that's this.
Why?
What does the bracket mean? Bracket means equal to. It can be equal to that. Curly brace, excuse me, not curly brace. Round bracket is not equal to.
Interesting.
Is that middle thing showing that the graph opens up?
Okay, so let me say all the things, yeah? I feel like, I don't know what happened. Maybe it was in the review unit or something. Last year, my Algebra 2 students knew how to do this all year. So I goofed somewhere. I don't know. Let me explain it to you real quick. You ready? Very simple. So this is an interval. So it exists from negative infinity to negative 5 halves. That's what the round bracket means. Doesn't include 5 halves. This is a union. It's not a U. It doesn't have a tail. It's a union. Okay? So it's this. Basically, that means it's this and this one. So everything between negative 5 halves and 1, not including either one of them. And then also 1 to infinity. Does that make sense?
Sure.
Yes.
Next year, if you take pre-cal, possibly if you take college algebra, depending on your college algebra class. But so I've said this before, and I will stress again. Let me say a few words. One of you probably knows that I'm kind of talking to them, but they'll get over it. I recommend taking math all the way through high school, whatever else you think you're going to do after. Even if you think you're not going to go to college, even if you're like really sure you're not going to go to college, because guess what? Plans change. And if you skip a year, all the math oozes out of your brain. So do a math all the years of your college. Here's my recommendations for your next year. I can give them all real simple for everybody in this room. If you currently are a junior and you think that there's a decent chance you're going to go to college, do dual credit. Go ahead and start it your senior year. Go ahead and jump into it. Go do dual credit. I'll be sad to see you go, but go do dual credit. Go do college algebra and then either statistics or trig in the spring. Do one of those. If you pass my class, even with a C, but like if you pass it with a B or better, you are easily prepared for college algebra. You can walk into that class and do great. You can probably pass the TSI first time without any trouble. You will do fine. If you are currently a sophomore, next year you're going to be a junior, take pre-cal. It's hard. You'll cry some. It'll be fine. Take it anyway. It's a good class. It's good for your brain. You'll be even more prepared for college algebra your senior year. Don't take some stupid thing. Don't take something blow off. It's a waste of your time. If you want to do Dave Ramsey's Financial Peace University, do it. It's a great class. Just don't pretend like it's a math. Don't pretend like it's a high school math class, because it's not. It can be if you do it. I've done that before. If you teach that along with a business math class, that's great. But Dave Ramsey's Financial Peace is not a fourth year math. It's not. Take a real math class. It's worth it. Pre-cal is fun. It's hard, but it's fun. It's great. You get to use a graphing calculator. I'm not just saying that because I want to torture you. If you take pre-cal with me, you get one more buffer year before you have to deal with college people. So do it that way. Does that make sense to everybody? You don't have to do anything I'm saying, but that is my strong recommendation. Anyway. This make sense?
Yeah.
Oh yeah, that's why next year you'll learn how to do set builder notation. You'll write the domain like this. You'll say the domain is x such that x is not equal to -5 halves and 1. X is an element of the real numbers.
Yeah.
You'll write it that way, but you don't know how to do that yet.
You can ask us to put domain and range on the test.
Yes, definitely. So range, so we're going to graph these soon. And the domain and range will make a little bit more sense when we graph them, probably, because you'll be able to see what they're going to look like when you graph something like this. Is it's going to look like something like this, probably. I don't know what this specific one looks like. We'd have to do a little bit more. It's going to look something wacky like that. And so there's going to be places on the graph where x and y don't exist. Make sense? The range is, skip the range on this lesson. It'll be easier once we get to graphing. Skip the range on ones like these for now.
Okay.
Because it'll be much easier when we start to look at graphs. What other questions from this lesson?
So do we not need to know how to do 18 through 26?
Let me confirm that I'm not being a liar. Yeah, no, you don't have to know how to do this. Because they're kind of dumb. They're not actually that hard. It's just matching, really, but no. Because after this lesson, we won't use that skill ever again. So
you're playing memory math without the memory.
something.
So just math.
Time is class over? Yeah, it's fine. Yes, you can leave. Thanks for asking.